Welcome to Homework Lib.
Hi, so in this case we're dealing with a weak acid that has a Ka equal to 2 times 10 to the minus 4. This implies that the pKa, that is minus the logarithm of Ka, will be equal to 3.7. Okay, so we have this pKa, and we know that the concentration of HCNO of the acid that we're going to get is zero point 0.2 molar because we have zero point 0.2 moles in 1 liter, and we have that the concentration of CnO minus that we're going to get is equal to zero point 0.8 molar. So in order to know the pH of this solution, the only thing that we need to do is employ the Henderson-Hasselbalch equation, that is pH is equal to pKa plus the logarithm of the concentration of the conjugate base. In this case, the conjugate base is CnO minus, divided by the concentration of HCnO, of my cyanic acid. Replacing the values, pK is 3.7 plus logarithm of 0.8 divided by 0.2. This gives us a pH equal to 4.3. Let's verify if the result makes sense. We have more of the conjugate base than we have of the acid, so we expect the pH to be higher than the pK, so everything matches up correctly. So now for the next question, we have question 7, is we are going to have now a buffer that is containing that is 500 milliliters that has zero point 0.2 molar of acetic acid, CH3COOH, and zero point 0.3 molar of acetate, so CH3COO minus. And we're asked what will be the pH of the solution after we add 20 milliliters of 1 molar NaOH. The other information that we have is that the Ka of this acid is 1.8 times 10 to the minus 5. Thus, the pKa will be equal to 4.745. Okay. So now, the first thing that we need to realize is that in order to get the pH, we need the amount of moles that we are adding of OH minus. That is going to be 20 milliliters, which is 20 times 10 to the minus 3 liters, times the concentration, 1 molar. Recall that molarity is equal to amount of mole divided by volume, so the amount of mole will be the volume times the molarity, giving us 2 times 10 to the minus 2 mole of OH minus. We can do the same calculation with the acid. In this case, I'm going to label it as acid, just to make it simpler for our notation. We are going to have 0.5 liters times 0.2 molar. So this means that we have 0.1 mole of acetic acid. Uh, I think that in this case, what I'm going to label it better as HAC for acetic acid. So over here, HAC. And for acetate, I'm going to use AC minus. Okay. So the volume is going to be the same, 0.5 liters times this is 0.3 molar in the acetate. So 0.15 mole of AC minus. We can also get the total volume of my solution, but as you're going to see, this is really not necessary. The total volume will be 520 milliliters, that is 0.52 liters. But I will show you that you don't need to use that at all in this case. So we can proceed with our ice table. We're adding a strong base, so that is going to react with the acetic acid that I have in solution. This is going to produce acetate plus water. Let's do our ice table in terms of moles. Of acetic acid, I am starting with 0.1. Of acetate, I am starting with 0.15. Of OH minus, I have added 2 times 10 to the minus 2, so 0.02. So the limiting reagent, of course, is going to be the OH minus. So the amount of change is given by that number. And over here, plus 0.02. Thus, at equilibrium, I'm going to get 0.08, something close to 0, and 0.17. Now we can use these quantities in amount of mole in our Henderson-Cassavell equation. Why is that? Let's see what happens if I do the division in between AC minus and HAC. That is the element that appears, right? This is equal to amount of mole of AC minus divided by total volume divided by amount of mole of acetic acid divided by the total volume. The total volumes are going to cancel out, and I'm going to find out that this is going to be equal to amount of mole of acetate divided by the amount of mole of acetic acid. So in our Henderson-Cassavell equation, we know that pH will be equal to pKa, that was 4.745, plus the logarithm of the concentration of AC minus divided by the concentration of acetic acid. This becomes 4.745 plus logarithm. We said that that was going to be equal to the amount of moles. So of AC minus, I'm going to have 0.17 divided by 0.08. The pH of the solution is 5.07, which is very close to 5.1. And that will be all. Thank you very much.